All right, so we're looking at lesson 124 today. And then tomorrow is y'all's free day. And then Wednesday we'll do lesson 125. And if you don't have to take a final, that is your last day. So anyway, hopefully for most of y'all, today is the 12th, yes. For most of y'all, Wednesday will be your last day. We're looking at point of division formulas. This lesson is strange. I don't know why we're really doing this one. I mean, like, I don't know why it's in the book at this point. It's like completely different from what we've done for the last like 15 lessons. I feel like it should have been a lot earlier in the book. It's just a strange placement for this lesson. You don't have to write this part unless you just want to. It's just a picture from the book. If you're going from 4 to negative 6, you know how to find the distance between 4 and negative 6, right? Distance of 10. But to go from 4 to negative 6, you don't go positive 10, you subtract 10, right? Like, because you gotta go backwards. Make sense? Okay. So that's where they get the coordinate change. The final coordinate minus the initial. Do y'all remember doing the problems that would say, like, find the number 3/5 of the way from 2 1/4 to 3 5/4? Y'all remember doing those vaguely, maybe? Towards like the middle, maybe second, third, 6 weeks. To figure out your number, you would want to use that formula. Do y'all remember that formula? Okay, well, we're going to be kind of using that this lesson, but instead we're going to be looking at points. You don't have to write this either. But you remember, if you had moved 3/5 of the way, you would say negative 10 times 3/5, and then add that to your original number. Y'all remember doing that? Okay, so that's what we're looking at today. So this is what you want to write. We're looking at coordinate points instead of just two numbers. So we're moving n over d, some fraction, from x1, y1 to x2, y2. So instead of just a number on your number line, you're moving on your coordinate plane. So they're talking about the change in your x and y values. Delta, usually in math, is going to mean change. So if you're taking another math and you see delta, that's probably what it means. They don't use delta to represent a variable. Like, do what? Yeah. So they're not going to let it be like x is just a variable. They're not ever going to say find delta. I mean, I guess they could, but usually it's going to mean like change. Kind of like pi has an actual value or like an understanding of what it is. Delta is going to pretty much always be change. So these two formulas, just what it was saying up here, the change in your x is the fractional distance between x2 and x1. Do you see how it kind of relates to the formula that we worked with at the beginning of the year? The fraction, and then your second coordinate minus your first one. Okay, so we want to find general equations. We're not actually going to have a point for our answer for this one. We just want to have an equation that'll give us the coordinate of the point F that lies 2/5 of the way between 2 points. I'm going to notate the x value for our point F like that. We're looking for the x coordinate, or the x part of our coordinate. And so you start with your x1 and you add the change in x. Does that make sense? And so we have x1 plus the change in x is the fraction, which is 2/5. And then what goes in the parentheses? x2 minus x1. Does that make sense so far? And then after that, all you have to do is simplify it algebraically. So you have x1 plus 2/5 x2 minus 2/5 x1. It's okay. And then we have 1 minus 2/5, which is 3/5 x1, and then plus 2/5 x2, and that is your general equation. Does that make sense? Yes? Y'all with me? Okay, so now we want to do the same thing for our y value. So we start with our y1, and then we're going to add the change in our y. The change in y, you do your fraction, which is 2/5, and then what goes in our parentheses? y2 minus y1. And then from here, all it is algebra. So y1 plus 2/5 y2 minus 2/5 y1. You have 1 y1 and negative 2/5 y1, which is 3/5 y1 plus 2/5 y2. You see how that works? Do you notice anything? Almost the same equation. The only thing that's different, x1 and x2, y1 and y2, right? But they end up being the same equation. So do you have to do both of them? You can work out one of them and then say, well, that's the x1, so the y1 must be pretty similar to that. Does that make sense? Okay, I'm going to show you a picture from the book real quick. Okay, I'm on page 676. You don't have to turn in the book unless you can't see this. Okay, so we've got our point here and here. The distance, that's the point that we're looking for. But to get this point, you have to go over x1 amount, right? And then go over whatever the change is. Does that make sense? Like we're going 2/5 of the distance, so this is the 2/5 of the distance between x1 and xf. But before we can actually get that value, we have to figure out what x1 is. So we go x1 over and then go over a little bit more. Does that make sense? And then the same thing with the y. So this is the change from here to here from the y value, but you have to add whatever you went up originally. You see how that works? Go with me? Okay. So we're going to look at one more example. Find the general equation for the coordinates of the point F that lies 3/7 of the way from point 1 to point 2, where P1 is x1, y1, and P2 is x2, y2. So to find our coordinate of our x part, we do x1 plus the change in our x. But what is the change in our x? 3/7 of x2 minus x1. You'll see where that came from? So x1 plus 3/7 of x2 minus 3/7 of x1. Now what? Add and subtract. Do you agree? 4/7 x1 plus 3/7 of x2. Okay, so that's our x value of our general equation for our x value. What about for our y value? What would it be? Right? Does it end up being the same thing? Mm-hmm. So what is it? Mm-hmm. So that's one of them, and that's the other one. Y'all see how that works? Kind of a strange lesson. Yep. Those are your equations. Any questions there? Okay. All right. There aren't any to omit on tonight's homework. But anyway, like I said, that's kind of a strange lesson. I don't know why they waited until the very end to do it.